Hi guys, welcome to section 7.1. We're going to be learning how to solve systems of linear equations in two variables. We kind of touched on it in the last lecture, but we're going to go into it in more detail here. So the objectives, we're going to verify solutions to a system of linear equations in two variables. So first we're going to learn how to verify that something is true. Then we're going to learn how to solve using substitution. Also, we're going to learn to solve using elimination. And then we're going to apply that to some word problems to see how that works. Okay, first thing is, what is a linear equation? Well, we already learned that it's a value to the first power. Remember, the exponent always has to be to the first power. So let's read what this says. A linear equation in n variables is an equation that can be written in the form a1x1 plus a2x2. What that means is that this could be like 2x1 plus 3x2 plus something plus 5x to the 10th, if there's 10 different x's, equals some value. That's a constant. B is a constant. So we can say, instead of B, we can say that's 6. So that would be a linear equation. Notice all of the variables are to the first power, okay? And all the a's, notice what this says, all the a values and the b are real numbers, meaning they can be any value that could be on the number line could be an answer, where at least one of the a's is not 0. Because if they were all 0, then we would have nothing, right? So they're saying at least one of them has to not be 0. Systems of linear equations in two variables. So a system of linear equations in two variables is the collection of two linear equations in two variables considered simultaneously. Well, let's say what that means. So let's say we have an x and a y. Then we have two different equations. So if we have an x and a y, if you want to solve for x and y, you have to have at least the same number of variables, same number of equations as variables. So since we have two variables, meaning two different values that change, x and y, we have to have two different equations. If we had three variables, we would need three different equations. We will not be working with more than two for this class, but you could have x, y, z, then you would need three equations. Okay, so first thing we want to do is we want to be able to verify. So it says show that the ordered pair -1, 3 is a solution to the system. Well, remember, if it's an ordered pair, it's always x comma y, right? So ordered pair. So here, for this one, basically I'm saying x equals -1 and y equals 3. So we just plug it in and see if it works. So we have, for the first equation, we have 3 times -1 minus 2 times 3 equals, well, let's see what it equals. Instead of saying it's equal to -9, let's see what it equals. So 3 times -1 is -3, minus 2 times 3 is -6, minus 3 minus 6 equals -9. So it works for that one equation. Now let's plug it into the second one. So we have -1 plus 3 equals, well, that equals 2, check. So now all we're doing is saying, yes, this ordered pair is a solution to both equations. So this is true, or this is a solution. However you want to state it, we know that this works, okay? I'm going to get to what this means in a little bit. Actually, I feel like I'd like to start with, let's just keep going. So verifying solutions to a system of linear equations. There's only three possibilities for the graphs. Okay, we're going to get to it right now. So if you were to graph any linear equation, what a linear equation basically means is that it graphs to a line, okay? So there's only three possibilities. Either the lines have different slopes and they intersect at one place, okay? So for example, we have two lines. Let's say one of them looks like that and the other one looks like that. Right here, where that meets, that is called the solution. So that's a solution to this system. These are consistent. Anything that has a solution, at least one solution, is consistent. So this is very important. At least one solution are said to be consistent. We will have things that have no solutions. Those are inconsistent. The consistent system has exactly one solution, so it is said to be consistent. Let me reread this because that's not what I said wasn't true. It's this consistent system, this one that I drew here, has exactly one solution right there where they meet. So it is consistent and it's independent. And we'll see the difference. So when something doesn't have a solution, it will be inconsistent. Dependent and independent, we'll see in a second. There are only three possibilities. So we already got one. So now let's look at the second one. The second one is the two equations can be different representations of the same line. So for example, if I were to draw this, let's say I were to draw a graph. So here's the equation of one line, right? And what if I were to say that the other line goes right over the top? They're the exact same equation, but they maybe look a little different. For example, like x plus y equals 3. If I multiply everything by 2, I get 2x plus 2y equals 6. Those are the exact same equation. So they would have a solution. It would be consistent, but they're dependent, right? Because they're the same exact thing. So it's consistent but dependent because they're the exact same line. Okay, they depend on each other. And then the last one, and we have pictures of them coming, but the last one is the two lines. If they have the same slope and have no intersecting points, it's said to be inconsistent and has no solution. So something like parallel lines are like train tracks. They basically run next to each other and they never intersect. So we can see here that if you have two lines that are parallel, which if they're parallel, they have the same slope, then we can see that this is inconsistent because there's no place that these two lines will cross, so there's no solution, okay? And here's the picture that I wanted to show you. So one solution right here. This one has infinite solutions. Every single point, do it in red, every single point on this line is a solution, and there's actually infinitely many points on the line. And here we have, it's inconsistent, it has no solution because they're parallel, okay? So how do we solve equations? There's a couple of different ways. The first way we're gonna look at is substitution. We've already actually used substitution in 1.2. I didn't call it that, but now we're gonna call it that. So again, we're gonna choose an equation and solve for one variable in terms of the other. And I'll show you how to pick. Sometimes it's easier to pick certain ones than other ones. Then we're gonna substitute the expression from step one into the other equation. And then once we do that, we're gonna have one variable instead of two. So substitute the value found in step 3 into one of the original equations to find the value of the other variable. So for example, here I have a system of equations, and we're going to use substitution. So I'm going to pick this equation because all the coefficients are 1. And it makes it a lot easier. If I use the top, I could use either one, but if I use the top one, then I'm going to end up having fractions, right? If I solve for x, x is going to equal something in terms of something else, but the other thing is going to have to be fractions. So I'm going to use this bottom one, and it doesn't matter if I solve for x or y. So let's subtract y from both sides, and I get x equals 5 minus y, okay? So I've taken that and literally just subtracted y from both sides, and I get x equals 5 minus y. And now I can just plug the y value in for x. So since I know x equals 5 minus y, I'm going to plug that in here for this x. So I have 2. Well, x is now equal 5 minus y. Minus 3y equals -5. And then we just solve this equation. So we have 10 minus 2y minus 3y equals -5. I'm going to combine like terms. So -2 minus 3 is -5y equals -5. Now I'm going to get y by itself. I'm going to isolate my y. So I'm going to subtract 10 from both sides. Those cancel, and I get -5y is equal to -15. Then divide both sides by a -5. The -5s cancel here, and I get y equals 3. So what am I looking for? I'm looking for an ordered pair. So I'm looking for an x, comma, y. And now I know y is equal to 3. Okay, so let's go back and find out what x equals. Well, I know that x equals 5 minus y because I've already said that's true, right? So that means that x is going to equal 5 minus 3, which equals 2. So my ordered pair here is 2, 3. Okay, so now we have our x, y. What does that mean? So now that I solved it, I didn't want to graph it because I can't graph it as well, unless I can't graph it as well to see where it intersects. But basically, if I graph these two lines, what we would find is that they intersect at 2, 3. And if you don't know how to graph and you need some help, I'll be happy to help you. But basically, that's what we're doing here. So notice here we have this one solution, 2, 3, which we already found algebraically. Okay. So that's the substitution method. So sometimes it's easier to use substitution because like we found variables here where it was easy to solve for x. But if we didn't have that, like if it was 2x plus 3y, then we would have something different. And using substitution would not be the easiest way to go. Okay, so elimination is most of the time really the way that you need to solve these equations. So let's figure out how we do that. So first, we're going to choose a variable to eliminate. That's why it's called elimination. And we do that by looking at both equations and seeing what's easy. And I'll kind of walk you through that. Then we're going to multiply one or both equations by an appropriate non-zero constant so that the sum of the coefficients of one of the variables is 0. Again, I'll explain that as we go. Then we're going to add the equations together. And when we do, we're going to get one variable because we're going to have eliminated the other variable. Now, once we only have one variable, we're going to solve the equation with one variable. And then we can substitute the value back into the equations and we can find the value of the other variable. Like we did with substitution, we actually did the same thing with substitution. So for example, I have these two systems and notice neither one has either a 1x or a 1y or a, so this is going to be more difficult to solve using substitution. So we're going to use elimination. How do we decide what to eliminate? Well, if we want to eliminate the x's, then we would have to deal with the -2 and the 3. If we wanted to eliminate the y's, then we would have to deal with the 5 and the 2. So I think what I might do is do it both ways so you can see what I mean. I usually pick the smaller values just to make it easier. So let's just rewrite this. So we have -2x plus 5y equals 29. And we have 3x plus 2y equals 4. Okay? And I'm going to eliminate x. That's the way I'm going to do it first. I'll do it both ways for you. So here I'm going to choose to eliminate x. And to eliminate x, I have a -2 and a 3, and I really want to find the least common multiple, which would be the same as trying to find the least common denominator if it was a denominator. But we're going to say the least common multiple. Well, it's going to be 6, right? So if I multiply everything here by 3 and everything here by 2, because that would be 6. And notice one's negative and one's positive, which I really like because when I add them, that's going to be 0, right? So what's going to happen here is I get -6x plus 15y. I'm just multiplying everything by 3, including the 29. So that would be 27, so 87. Yeah, I don't think I made a mistake. And here we have 6x plus 4y equals 8, right? Because I'm multiplying each one of these by 2. And now when I add these two equations together, notice I've eliminated the x. And what I get is 19y is equal to 95. I divide both sides by 19. And I get y equals 95 over 19. And then I just want to see, is this an actual value? So 95 divided by 19 is equal to 5. So I get y equals 5. Okay, well, great. Now that I know what y equals, so we're starting our ordered pair. We know y equals 5. Now, honestly, I can use either one of the equations to find x. So again, I think I'll pick the smaller one because it just makes things easier. So I'm going to say 3x plus 2, and we already know y is 5, times 5 equals 4. 3x plus 10 equals 4. I subtract 10 from both sides. I get 3x, the 10's cancel, equal -6. Divide both sides by 3, and I get x equals -2. So now I have my ordered pair. My ordered pair is -2, 5. If you plug that in to both equations, it will work, which means that I have one of those graphs that if I were to graph it, it would look it wouldn't look like that because it has to intersect at -2, 5. So let's see. So if here's -2 and here's 5, That means both graphs are going through that point. I'm not going to figure out exactly what it looks like, but one of them could look like this and the other one could look like that, right? Because we have one solution. So let's do the exact same thing. Let me copy this. Let's do the exact same thing, but now I'm going to eliminate y first, okay? So again, I start with minus 2x plus 5y is equal to 29. 3x plus 2y is equal to 4. Now, what do I multiply by? Well, the least common multiple between 2 and 5 is 10. Okay, so I'm going to multiply this by 2 and this by, now notice if I multiply it by positive value, when I add those two equations, I'm not going to eliminate anything. So I'm going to multiply this by minus 5. So what do I get? I get negative 4x plus 10y equals 58. And I get negative 15x minus 10y is equal to minus 20. So don't forget you're multiplying every term, including the answer, by negative 5. Then when I add these together, again, now the y's cancel, so I'm eliminating y. And I get minus 19x equals, and then 58 minus 20 is 38. I divide both sides by minus 19. And I get x equals negative 2, which is exactly what I got before. And now I have to find my y, so I can pick either equation. I don't remember, I think I picked the bottom one because it was easier. We'll pick the top one this time. I have, let's put in this little box here. So I have x equals negative 2. So I have negative 2 times negative 2 plus 5y is equal to 29. This becomes 4 plus 5y equals 29. I subtract 4 from both sides. This cancels, and I get 5y equals 25. Divide both sides by 5, and I get y equals 5. So again, I get the same ordered pair minus 2, 5. I just, in one way, I eliminated one variable first. First, I eliminated x, and now I have eliminated y. No, that's right. First, I eliminated x. Here, I eliminated x. And here, I eliminated y. Doesn't matter, same answer. So let's do it again. Now, this one, we could do either way, right? I could either solve this using substitution, because I can easily say, if I add 2y to both sides, I can say x equals 11 plus 2y, or I can use elimination. Unless something's super easy, I would practice the elimination if I were you, because most of the time elimination works. I wouldn't say better, but it always works where substitution doesn't always work as easily. So let's begin. X minus 2y equals 11, and minus 2x plus 4y equals 8. Okay, so it just depends on which variable you want to eliminate. I'm going to eliminate x first. I like that because, well, I guess it's pretty much the same, but anything that has a 1 as a coefficient is always going to be easier to eliminate. So what am I going to do? I'm going to multiply everything here by 2. So I get 2x minus 2y equals 22. And here I get minus 2x. Sorry, I didn't multiply, I didn't distribute. So minus 4y equals 22. Minus 2x plus 4y equals 8. Now, when I add them together, notice this cancels and this cancels, and I end up with 0 equals 30. Well, 0 never equals 30, right? So I can say for sure that this has no solution. If I were to solve it, I'd find out that the slopes are the same. If I would have solved these for y, I would find out that they both have the same slope. They're parallel, they're inconsistent because there's no solution. So how do we write the answer to this? That's another, well, I guess, I don't know. I don't think we have to do what I was thinking. So if we were to do, if we were to actually write a solution, which I don't believe you have to, but let's just do it in case. So I could say that my first solution, so my solution is, let's say here, I change this to x equals 11 plus 2y, or 2y plus 11, because I added 2y to both sides. Well, then what I could say is, well, I don't know what y is, but once I do know what y is, x is going to be 2y plus 11. So if I pick y equals 1, I know x is equal to 13, and so on. So there's no solution because I don't know exactly what those values are, but I can write an answer. I don't know or believe that you will have to do that, so I'm not sure.